All right, so we did the first two. Now we're going to come and do the, so you notice the first two we gave you an angle and a side. The second two, we're going to give you two sides. So the first two you tended to use like the so, the ka, or the toa to get started. Once you got two sides, you're just going to use Pythagorean theorem for the most part to get the other side. To me, these are actually easier. So let's look at the first guy, number 43. So we know this guy is 5, this guy is 4. If you looked at this guy, what would you guess? What would you guess?
What would I guess? 8.
Yeah, 7 or 8, something
Yeah.
like that, right?
Yeah.
I mean, it's obviously the hypotenuse, so he's a little bit longer. Okay, so let's get that side. So the hypotenuse, we know a squared plus b squared is equal to c squared. Therefore, c is equal to the square root of a squared plus b squared. And so c is equal to the square root of, so we got 5 squared plus 4 squared. So c is equal to the square root of, what's that? 25 plus 16, 41?
Yep.
So it's the square root of 41. So this guy is the hypotenuse. He's the square root of 41. To get a little feel for that, we'll just check. You can leave your answer like that. I like to be able to eyeball it. So get the 6.4. This is square root of 41. I guess approximately 6.4. Okay. So now which you can buy. He's a little longer than the 5 guy. 25, 35, 41. Okay. So let's get an angle. The angle I would go for. Well, you can pick either angle. I just picked this angle. I just picked it because it happened to be closer to my pen. Right? Doesn't matter. So we'll call this angle theta. And so how are we going to get theta? I would use the information that we originally given. So if that's theta, this guy is the opposite because he's opposite theta. This guy is adjacent because he's the touching guy. And so I would use the TOA to get that angle. So from the TOA, which says the tangent of theta is equal to the opposite over the adjacent. Therefore, to solve this guy for theta, you have to take the inverse tangent of both sides. Take the inverse tangent of the tangent of theta. Whatever you do to the left-hand side, you got to do the same thing to the right-hand side. So you get the inverse tangent of the opposite over the adjacent. And so this, what is this function, the inverse tangent? It's the function that undoes the tangent. So when you take the inverse tangent of the tangent, you just get out what you originally had, which was the angle theta. Therefore, I'll come up here, we can say theta is equal to the inverse tangent of the opposite over the adjacent. So theta is equal to the inverse tangent of the opposite guy. Who's the opposite guy?
5.
The 5. So we got inverse tangent of 5 over 4. So now it's a calculator problem. Make sure your calculator's in degrees mode. Take the tangent. We get 51.3 degrees. So for this guy, I get 51.3 degrees. And then this angle is going to have to be 90 minus 51.3 degrees, which happens to be 38.7. So this angle is going to be 38.7 degrees. So there you have it, 38.7, 51.3, and the hypotenuse was the square root of 41. Okay, so we're down to the last triangle. Okay, so the last triangle, we've got this guy. Who's this guy?
Hypotenuse.
Okay, he's the hypotenuse, or in Pythagorean theorem, he's the C guy. So, and we've got one of the sides. So we're gonna
Adjacent.
well, it depends on which angle. It's a good point. He could be the adjacent. He could be the opposite. It depends on who we choose as our angle. You know what I'm saying? So we'll call this. We'll go with your adjacent. We'll call this guy theta. Then it would be the adjacent. Okay. So we got a squared plus b squared is equal to c squared. We got the c. We'll call that guy the a. So let's try to get the b. So to get the b, we got to subtract a squared from both sides. And so we get b squared equals c squared minus a squared. Therefore, b is equal to the square root of c squared minus a squared, which in this case is the square root of 7.20 squared minus 4. It's 4.00. Let's write it as 4 squared. So since it's not nice round numbers, I'll get the decimal version of that guy. So we got 7.2 x squared. Take the square root. We get 5.99. So b is equal to 5.99. So I can believe that. So this side is 5.99, and if that's our angle, this guy is the opposite, and this guy is the adjacent. So now, what are we left with? We're left with just getting an angle. So this time, to get the angle, I always kind of like to start with the information that was given. So I'll just use the 7.2 and the 4. And if we use the 7.2 and the 4, since we got the adjacent and the hypotenuse, I'm going to use the caw. Caw. So there's the caw, which says cosine of theta is equal to the adjacent over the hypotenuse. So we do the same trick. To solve for the angle, you got to take the inverse cosine of the cosine. And that's equal to the inverse cosine of the adjacent over the hypotenuse. So the inverse cosine undoes the cosine, so you're just left with theta is equal to, so on the left hand side you just get theta. Theta is the inverse cosine of the adjacent over the hypotenuse. And so theta is equal to the inverse cosine of 4 over 7.2. And we get 4 enter 7.2 divided by arc cosine. 56.3 degrees. So we get theta equals 56.3 degrees. So that's this guy, 56.3 degrees. And this guy is going to be 90 degrees minus 56.3 degrees, which is what? That's 30. Or should I? 33.7.
7.
There you go. So we get 33.7, 56.3, and for this side we got the 5.99. All right, so that's all the right triangles. Hopefully you get this one. You try to get on your own, see if you can do them by yourself. All right, have a good day, and happy holidays. Cut.